Hi guys, I welcome you all to our channel. So here we are going to start with another very important and famous topic of data structures and algorithms. So it is a binary search tree. So here in this session we are going to discuss in a smart way regarding what all the important hints that we are going to see in binary search tree, so that may arrive in examination point of view. So once it has been discussed, we are going to move into its problematic areas. So that is a very important one you must have to take into consideration, friends. So in that area also you may be able to get questions, friends, right? So without any delay, let me start this session. So binary search tree. So what is this? So this is one of the technique that we are using in binary tree. So this is also, we can tell that one of the method of traversing and finding the node values that is being present in a tree. So suppose if we just see a tree, we have left children, so that is I am talking about binary tree, okay. So we may have left children and right children and a root node. Okay, so we were using traversal types for using any type of the path in order to select that value or in order to reach that value. Okay, so this is one of the type of a data structure. Similarly, so this is also one of a technique where we are going to apply for storing the nodes in such a way that we are going to choose any one of the direction. Okay, so we are not going to traverse all the directions as it will cause a waste of time. Okay, so we are going to use this technique in such a way that we are going to traverse in any one of the directions, so that is minimal direction, so that easy way of searching a value can be represented. Okay friends, so now what is the technique? So that we are going to see over here, friends, right? So before going into the example explanation, so these are all some of the short hints which I have written over here. Okay, so please make a note of it so that you will be feeling it easier for understanding its concepts. These hints and its applications that I am going to write it over, and then the way of solving if a problem is being asked here, friends, right? So now, the another name of binary search tree is ordered or a sorted binary tree. Okay, so these are all the words you must have to remember. So the another name of binary search tree is ordered binary tree, or it is also called as a sorted binary tree, friends, right? Then next, the nodes are arranged like a linked list. So you must have to underline this point. Okay, so normally we will be creating a tree in a hierarchical manner, isn't it? So we will be having a connection between the root node and left nodes, right nodes, and so on. So those links are maximum it is being implemented by using the data structure which is called as the linked list. Okay, so if anybody didn't watch this linked list video, I request you to watch, right, so that it will be easier for you to understand, friends, right? Then node value of a tree is as. So this is a very important point. So by using this technique only, we are going to construct binary search tree. Okay, so see, the word is search, meaning is I am going to search a node value based on the data structure implementation which is being done using linked list, friends, right? So what is this? See, left nodes is always lesser than that of right nodes in a binary tree. We are going to construct a binary tree in such a way that all the left nodes, okay, all the left nodes that are being present under the main root node will be always lesser than that of the right nodes. Okay, that is the left subtree values will be lesser than that of the right subtree values. Similarly, right nodes will be always greater than the left node. Okay, so right nodes are always greater than the left nodes. The values that we are going to store in the right nodes will always be greater than that of the what? Right nodes. So now, see, this is one of the very important point. Okay, if we are going to apply in order, that is after constructing this binary search tree, I am going to apply in order traversal in order to display the list of values that is being present in a tree, binary tree. So if I am going to apply and find all the values that is being stored under there, it will be in ascending order, friends, right? So all the values whatever that I am going to recover from that binary tree, those values will be arranged in an ascending order format. So this is a very important point, make a note of it. So in binary search tree we are going to apply in order so that the values will be in the form of ascending order representation, right? So some of the applications where we are using this binary search tree is very important point. So first one is sorting trees. Okay, please make a note. So sorting trees, we are going to use this binary search tree because see, all the nodes in the left subtree are lesser than that of the right node. So based on this we can apply sorting techniques. So tree sorting we can use. Then another application is we can implement dynamic sets construction by using this binary search tree. You needn't want to study in detail, friends, just to make a note of it. So they may ask in MCQs. The next one is we can implement priority queues by using this binary search tree. Right, friends? So now we can go for how to implement these binary search trees, right? Okay. So friends, this is the given question. So for this question we are going to apply the way of constructing binary search tree for the given set of node values, right? So how we can construct? So always the values are given in the list, isn't it? Always start from the first value. Okay, so this is my first value. Start from the first, and for each and every level I must have to compare with the root node. Okay, just watch. So this is my first value. Okay, so start. As there are no tree present, this is the fresh one. First value is always going to be your root node. Okay, so this is your, now the tree is free, isn't it? So this is the first node that is being coming. So always the first node will be a root node, friends, right? So mark it as root node 5. Okay, friends. So now what is the next node? How we are going to insert this 7? So now compare each and every level, isn't it? So now 5 is a root node and 7 is the new coming value. So now compare 5 with that of 7. Okay, if the incoming value is lesser than the root node, friends, right? If the incoming value is lesser than the root node, left node. If it is greater than the root node, then it is your right. Can you understand? If the incoming value is lesser, left, greater, right. Okay, understand? So please make this sound, lesser, left, greater, right. Okay, so lesser, lay means left, greater, the sound is R sound, isn't it? So it comes under right. Meaning is lesser, left, greater, right. Like this you can remember, it is one of the tricks so that you will be able to not forget at any cost, right? So now this value is greater than that of the root node, greater. So gray, where I should have to insert? This side. So put here, friends. Friends, is it easy the way I am just telling you? Right. So now this being finished. So now what is the next node? So next node is going to be 1. Okay. So 1 you compare with the, see friends, always start from the first point, first level. So 1 is always lesser than the root node, isn't it? Lesser means left, lesser left. So put here. As there are no nodes present here, I am adding it directly. Right, friends? So now this is being finished. So what is the next node? So next node is going to be 8. So 8, start from the first level. So 8 is greater than 5, isn't it? Since it is greater, gray, move towards right. Okay. So again you see I cannot insert here because there is another one node that is being present, 7. So compare this 7 with 8. So 7 is what? Lesser than 8. That is incoming value is greater than the root node. Incoming value is greater than the root node. So greater. So put here. Can you understand? Okay. See, incoming value greater means right side. Okay. Then incoming value is lesser means left. Okay. Greater right, lesser left. Please make a note of it. Next, what is the value? So the value next is 3. Okay, the value next is 3. So start from the root node as usual. So the incoming value was lesser than 5, isn't it? So, incoming value is lesser than the root node, then move here. Okay, I must have to travel only left, isn't it? So, again here there is one more value 1. So, this incoming value is lesser than this root node, am I right? So, as I am going to insert here, this is going to be your root node, right? So, now incoming value is greater than 1. Okay, so greater than 1. So, what I should have to do? Greater, right? So, insert here as 3. Friends, can you follow? Right. Suppose if we cannot understand, please watch from the beginning of the solution. You will be able to have a way of solving this, friends, right? So, next is 6. So, start from the root node. The incoming value is greater than the root node, isn't it? The incoming value is greater. So, move towards right. So, again there is another one node. So, the incoming value 6 is lesser than the root node, isn't it? Lesser than the root node because 6. So, you can insert over here, friends. Can you follow? So, now 6 is finished. So, next is 9. Again start from the root node. So, 9, the incoming value is greater than the root node. So, I must have to traverse right, isn't it? Again there is one value 7. Now, 7 is the root node. So, 7 is greater than, the incoming value 9 is greater than the root node. So, where I should have to move? Right. Can you understand? So, again compare this 9 with 8. So, the incoming value is greater than 8. Okay. So, put it over here, friends, right? As there is free space here, I am just adding it, friends, right? So, this is over. Next 4. I think now it is familiar for you, right? So, 4. So, 4 is less than 5. This side you must have to come. So, 4 is less than 5, come this side. So, again compare with the root node, 4 is greater than this root node. So, move this side, right, greater, right. Again there is another one value present. Now, at this instant, this is your root node. Friends, can you follow? So, 4 is lesser than or greater. So, 4 is greater than 3. So, this side only I should have to insert, as there is no value present, I can insert here. Now, for 3, 4 is greater. Can you follow? So, for each and every level if you check, always left nodes will be lesser, right nodes will be greater. For each and every level if you check, you can be able to understand. Next is 2. Now, compare 2 with the starting level. So, 2 is less than 5, isn't it? So, lesser than left. Then 2 is, you must have to compare with 1. So, 2 is greater than 1. So, right, greater, right. Again there is one node, check. So, 3 is greater or less. So, 2 is lesser than the root node, lesser. So, put here as there is no values present over here. So, friends, if you see, we have inserted all the nodes. Okay, are you all clear? So, for each and every level, I must have to apply this condition. So, incoming value is greater than the root node or incoming value is lesser than the root node. Very important point, please make a note. Okay, friends. So, friends, let me apply and see the in-order traversal for this binary search tree so that whether the values are arranged in ascending order or not. Right? Now, shall we do? So, what is an in-order traversal? Please recall and tell me. So, in-order traversal is I am going to traverse the given binary tree in left node first, root node and then the right node, isn't it? L, N, R. N stands for root node. So, all these things I have explained it to you. So, based on that we are going to do. Suppose if you are going to find the root node based on the rule given, write it directly. If you are going to move towards left node, okay, if that node is a child, we are going to write. If it is going to have a further subtree, for that subtree, once again I must have to apply the in-order traversal. Friends, please review and see, you will be having a clear idea. So, now let me apply the in-order traversal. So, in-order. So, what is the in-order traversal? So, it is left node, root node and then right. So, this is the condition, left node, root node and right. So, let me start from here. So, initially for this is my root node. First I should have to complete left. According to this level, all the left node should be finished, and then root node, and then the right node, friends, right? So now we will start. So this is my root node at the beginning. So you should have to move to left because it is being given here left. See, so you are having a subtree. Okay, so still it is extending further. So once again you just apply the in order for this one. So left, okay, so left is empty. See friends, like this only you should have to apply. So this is one subtree. Can you understand? So left is empty. So 1 is my root node, 1 is my root node, and then I should have to write my right node. So I cannot write here right because right node is still extending. So this you should have to consider. This you should have to consider. So if you see left, root node and right, can I write like this? Yes. So 2, 3 and then 4. Okay, so according to this place, if you see, all my left node, left subtree has been completed. So after left node finishing, what I should have to write? My root node. So 5. Now you jump to this right subtree. So finishing this root node, you have right. Okay, so but this is not my child node. Still I am having a subtree, isn't it? So apply here the, as usual, the in-order traversal. Left, okay, so left is my child node. Since there is no any other extension, stop. Otherwise I must have to proceed here. Okay, so 6, I can write 6, then 7 and right node is 8. But if you see, right node is still extending. See, like this. Can you follow, friends? Okay, so this is one subtree for this right node. So finish that. So left is empty, root node is 8, left, right and then left, root node and then right. So root node I have written. What is the remaining right node present? So 9. This is my child node. There is no extension. You can stop. So 9. Can you follow? So when you just find the answer for the binary search traversal, binary search tree, while applying this in order traversal, okay, what is the answer? So answer is in the form of ascending order. You see 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so this is the way you are going to implement binary search tree. So after implementing this BST, that is binary search tree, you can check your answer frequently by using this in order traversal. So once you have finished this, if you check this answer, you are going to get the result in ascending order. So if you are getting this, it means the BST what you have constructed is right. Okay friends, I think so this session will be very understandable one for you, right? So what you must have to do is take another one question. Okay, take another one series of values. You yourself try to construct this BST. Okay, if you go on practice, you will be able to get it right, friends. So practice makes a man perfect, isn't it? So get trained nicely. Okay, so suppose if you cannot follow, already told, watch from the beginning, so you will be able to understand. Okay friends, so that's all in this session. So we are going to see in the next video how we are going to delete a node, how we are going to insert a node by using binary search tree. Okay, very important session. Okay, I think you should not miss it. Okay friends, so thank you for watching, and I request you to watch and share so that all of the students will be getting benefited out of this, friends, right? So thank you.